Here is our first question on the screen. The values of current I flowing through a given resistor of resistance R for the corresponding values of potential difference V across the resistor are given below. Plot a graph between V and I, find the value of R. So here a table is given. On the basis of this table, we have to plot a graph between V and I. So let's see. Let's take this axis as V and this axis as I. Now take the values. Take this as 0.1, this as 0.2, this as 0.3. And here take this 0.5, this 1.0, this 1.5, and this 2.0. Now let's see the table. In the table, the voltage is given 0.5. So this is 0.5 and the corresponding current is 0.1. This is 0.1. So let's meet them and we get a point here. This is the point we get. Alright, now when the voltage is 1 volt, then the current is 0.2 ampere. So let's meet them and we get this point. Now the voltage is 1.5, this, and the current is 0.3, means this. So let's meet them. And we get this point. Now meet these points and this gives a straight line. It means the graph plot between V and I is a straight line. Now we have drawn the diagram, which is a graph between V and I. Now we need to find the value of R. So how to find the value of R? Let's see. Take any 2 points. Okay, we have to name them like A, B, and C. So we have named them, these points we have named as A, B, and C. Now take any 2 points, like we are taking A and B. Then the value of R will be given as R is equal to VB minus VA upon IB minus IA. As we know that R is equal to V upon I. So here in this case, VB minus VA upon IB minus IA. Now put the values of them. The value of VB means at the point B, the value of V is 1.0. So this is 1.0 minus VA. At the point A, the value of V is 0.5. To put the value 0.5 upon the value of IB, means the current at the point B. This is the point B. The current is 0.2 at this point, minus IA, means the current at the point A. At the point A, the current is 0.1. This. Now we need to solve this. The value of R becomes, the value of R is 1.0 minus 0.5 upon 0.2 minus 0.1. So let's solve it. 1.0 minus 0.5, it becomes 0.5 upon 0.2 minus 0.1, it becomes 0.1. So we get the value of R as 5 ohm. This is the value of R with the help of this graph and the table given. The potential difference between the terminals of an electric heater is 60 volt when it draws a current of 4 ampere from the source. What current will the heater draw if the potential difference is increased to 120 volt? So here two conditions are given for an electric heater. In the first condition, the potential given is 60 volt. Let's take this as V1. And then in that condition, in the first condition, it draws a current of 4 ampere. Now in the second condition, what current will heater draw? Means in the second condition, the current we need to calculate. What current will it draw? If the potential difference is increased to 120 volt, now the potential difference becomes 120 volt. This is the potential difference in the second condition. So we need to calculate this I2. How to calculate? Let's see. Since the electric heater remains the same, means the resistance of this will be same in both the cases. In the first case, R is equal to V1 upon I1 from Ohm's law. In the second condition, the R will be same since the heater is same. So R will be V2 upon I2. Now we need to equate these two values of R. So equate them. V1 upon I1 is equal to V2 upon I2. Now put these values. The value of V1 is 60 volt upon the value of I1 is 4 ampere is equal to the value of V2 is given 120 volt and I2, this we need to calculate. When we solve this like this, 6 2s are 12 and 2 4s are 8, we get the value of I2 as 8 ampere. This is our answer. Find the current drawn from the battery by the network of 4 resistors shown in the figure. Here a figure is given in which 4 resistors are connected as shown. So we have to find out the current drawn from this battery. Okay, let us consider the current drawn is I. And this current, when reaches to this point, it divides into two parts. Let us take first part as I1 and the second part as I2. So this part I1 flows through this resistor and this resistor. Means this I1 is same for this 10 ohm, this 10 ohm and this 10 ohm. It means in these three resistors the current is same, which is I1. So when the current is same in these three resistors, it means these three resistors are in series. So we need to calculate the resultant of these three resistors which are in series. So let us calculate. So the resultant of these three resistors will be given as RS, that is R series, is equal to R1 plus R2 plus R3. Put their values, which is this 10 ohm, 10 ohm and 10 ohm. Let's add them up, then we will get 30 ohm. This is the value of these resistors which are connected in series. So this is the value of these three resistors. So we will remove these three resistors and we will place the resultant of them. We can reduce these three resistors by their resultant because we have calculated the resultant of these three resistors. So let's see. So we have removed these three resistors and the resultant of these three resistors is 30 ohm. Now this 30 ohm carries a current I1 and this 10 ohm carries a current I2. So these two resistors are having the currents which are different. When the currents in two resistors are different, then these two resistors will be in parallel. So let us calculate the resultant of these two resistors. So first one is 30 ohm and the second one is 10 ohm, and these two are in parallel. So in case of parallel, how do we calculate? We calculate like this. This is the resistance, the resultant resistance in parallel, which is given as 1 upon R1 plus 1 upon R2. R1 in this case is Rs and R2 in this case is this R. Now put their values. This will be 1 upon 30 plus this will be 1 upon 10. So this is the value of 1 upon Rp. So 1 upon Rp is equal to, let us take the LCM. The LCM of 30 and 10 will be 30, and here will be 1 and here 3. So this will be equal to 4 upon 30, or we can say the value of Rp will be, we will reciprocate both the sides, 30 upon 4. Let us divide it by 2. So this becomes 2 15s are 30 and 2 2s are 4. So this becomes 15 upon 2 ohm. This is the resistance which is in parallel. Now watch the figure again. This, the resultant of these two resistors is 15 upon 2. 15 upon 2. So we will reduce these three resistors and we will place 15 upon 2 in the place of these two, because the resultant of these two resistors is 15 upon 2. Okay, let's remove these two resistors. We have removed these two resistors and the resultant of these two is 15 by 2 ohm. Now we have the value of the resistance, which is 15 by 2 ohm, and the value of potential, which is 3 volt, and the current we need to find out. So with the help of V is equal to IR, we can calculate this I. From here the value of I will be I is equal to V upon R. We will put the value of V, which is 3 volt, and put the value of R, which is 15 upon 2 ohm. Then we can calculate the value of I. So let's calculate. I is equal to V upon R. The value of V is 3 volt and the value of R is 15 upon 2. 15 and 2 comes here. So let's divide them. 3 5s are 15 and this becomes 2 upon 5. This is the value of current, 2 upon 5 ampere. This is the answer. The figure below shows three cylindrical copper conductors along with their face areas and lengths. Discuss in which geometrical shape the resistance will be the highest. So in these three cylinders we have to find it which one is having the highest resistance. Okay, these three cylinders are made of copper. It means all the three have the same specific resistance, that is rho is same for all these three resistors. The rho is same. So now find out the resistance for this one. That will be, let's take it as R1 is equal to rho L upon A. Rho L, L means length, which is L, upon A. A is area, which is A. And in case of this, find out R2. Here rho L, L here is 2L, so it becomes rho into 2L upon A. A in this case is A by 2, so take this A by 2, A by 2. Now this R3, in this case take as R3, is equal to rho L. The value of L is here L by 2, L by 2, and the area is 2A. 2A. So these are the values of the resistance in these three cylinders. Now we need to calculate in which one the resistance is higher. So let us calculate. In the first one, the resistance is rho L upon A. In the second one, what will be the resistance? Let's see. Watch here. This 2 comes in the numerator and makes it 2 to the 4. So this will be 4 rho L upon A. In case of R3, watch here again. R3, this 2 and this 2 multiply together to make 4, and this is 1 upon 4. So watch here, this becomes 1 upon 4 times rho L upon A. Now you can clearly see this is rho L upon A, this is 4 times rho L upon A, and this is 1 by 4 rho L upon A. So we can say that the R2 is the highest. Then comes R1, and at the last comes R3. This is the order. Calculate the equivalent resistance between A and B in the following electric circuit. So we have an electric circuit over here. We have to calculate the resultant resistance between A and B. In these kind of problems, we start from here. So this 10 ohm and this 2 ohm, these two are in series. This 10 ohm and this 2 ohm are in series. So let us calculate the resultant of these two resistors, which will be 10 plus 2 equal to 12 ohm. So the resultant of this 10 and this 2 is 12 ohm. So we can remove them and we can put the resultant of these two resistances. So let's remove them. So we have removed these two resistors, and in the place of them we will put the resultant of them, which is 12 ohm. The resultant of these two is 12 ohm. Now this 12 ohm and this 6 ohm, this 12 and this 6, these are in parallel. So these two are in parallel. How to calculate the resultant of the resistors in parallel? We will take this. So these two, one is 12, another is 6. The LCM will be 12, and this will be 1 plus 2. So the value of RP will be, let's reciprocate here and here. This is 3 upon 12, it becomes 12 upon 3, or 3 4s are 12, this becomes 4 ohm. The value of RP is 4 ohm, means the resultant of this 12 ohm and this 6 ohm is 4 ohm. the resultant of this 12 ohm and this 6 ohm is 4 ohm. So let us remove these two resistors and let us place the resultant of them. So we have removed these two resistors. In the place of them we will put the resultant of them. So the resultant of them is 4 ohm. Now this 4 ohm and this 8 ohm, these two are in series. This 4 ohm and this 8 ohm are in series. The resultant of this 4 ohm and this 8 ohm we will calculate like this. Let us take it as RS dash, which will be equal to 4 plus 8, 4 plus 8, and it becomes 12 ohm. So the resultant of this 4 ohm and this 8 ohm is 12 ohm. So we will remove these two resistors and we will place the resultant in place of them. So let us remove them. So we have removed these two resistors and the resultant of them is 12 ohm. So let us put the resultant of them, which is 12 ohm. Now this 12 ohm and this 6 ohm, these two are in parallel. Why these two are in parallel? Because the current will not be same in these two resistors, because the current will divide at this node. Whenever the current divides, the resistors will be in parallel. Whenever the current does not divide, it means the resistors will be in series. I have told you in the last problem. So this 12 ohm and this 6 ohm, these two are in parallel. So the resultant of this 12 and this 6 ohm, which are in parallel, we will calculate. How to calculate? We have done this before. This 12 and this 6 we have calculated as Rp, and this Rp is equal to 4 ohm. So the resultant of 12 ohm and 6 ohm, which are in parallel, the resultant of these two will be 4 ohm again. So remove this 12 ohm and this 6 ohm and place the value of resultant, which is 4 ohm. So let us remove these two. So we have removed these two resistors. In the place of them, let us place the resultant of these two, which is 4 ohm. So we have put here 4 ohm. Now this 4 ohm and this 4 ohm, these two are in series. These two are in series. So let us calculate their resultant. So we will take as RS double dash, which is 4 ohm plus 4 ohm. It becomes 8 ohm. So the resultant of this 4 and this 4 is 8 ohm. Why? Because these two are in series. Come here again. Watch here. The resultant of this 4 ohm and this 4 ohm is 8 ohm. So let us remove them and place the value of resultant. So we have removed them and the resultant of these two is 8 ohm. So let us place here 8 ohm. Now this 8 ohm and this 8 ohm, this 8 and this 8, these two are in parallel. The resultant of these two, let us calculate. So the resultant of these two, which are in parallel, will be given as 1 upon 8 plus 1 upon 8 is equal to 2 upon 8 or 1 upon 4. So reciprocate both the sides, we will get the resultant of these two as 4 ohm. So the resultant of this 8 ohm and this 8 ohm is 4 ohm. So let us remove these two and place the value of resultant. So we have removed these two resistors and the resultant of them is 4 ohm. So let us place here 4 ohm. Now this 4 ohm and this 4 ohm. These two are in series. These two are in series. So the resultant of this 4 ohm and this 4 ohm, let us calculate. Yes, we have calculated. The resultant of 4 ohm and 4 ohm which are in series becomes 8 ohm. So watch here. The resultant of this 4 ohm and this 4 ohm becomes 8 ohm. So let us remove these two and place the value of resultant. So we have removed these two resistors and the resultant of them is 8 ohm. So place here 8 ohm. Now this 8 ohm and this 8 ohm, these two resistors are in parallel. So the resultant of these two resistors which are in parallel, let us calculate. The resistors 8 ohm and 8 ohm are in parallel, the resultant of them. So watch here, we have calculated 8 ohm and 8 ohm which were in parallel. The resultant of them comes 4 ohm. So let us remove these two, this 8 ohm and this 8 ohm. The resultant of these two will be 4 ohm. So let us remove these two and place the value of resultant. So we have removed these two resistors and the resultant of them is 4 ohm. Now this 4 ohm and this 6 ohm, these two are in series and the resultant of these two will be 6 plus 4, which will be equal to 10 ohm, and this is the end of these resistors. So all the resistors are included and finally we have calculated the resultant, which is 10 ohm. This is the equivalent resistance between A and B. This is our answer.